Hello and welcome to Gabriel Marcolini's Mr. Parsons Glucose Project Improv skit. And I hope you enjoy it and learn something. Yeah, I really do. Glucose, the glucose guy. Glucose, 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 glucose guy. Glucose, 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 the glucose guy. Glucose, 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 the glucose guy. Glucose, the glucose guy. Glucose, 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 the glucose guy. Cool. Hello, this is the first episode of Gabriel Marcolini's Glucose Science Mr. Parsons project. And it's going to be really good. It's about cellular respiration in the molecule known as glucose that is involved in cellular respiration, if you get what I'm saying. Alright, so just hang tight, and I'll only be a quick second. Before cellular respiration can happen, a glucose molecule first must be broken down into smaller pieces so it can be used for energy. This is called glycolysis, and it's when a glucose molecule is broken into two parts, which contains pyruvic acid and a 3-carbon compound. This is now going to be broken down. Ooh yeah, we're breaking it down. Yep, we're breaking down the glucose. We're breaking it down, broken down. And now, you can look right here. We have got the 3-carbon compound and the pyruvic acids. Now we're ready for the process of cellular respiration to begin. This is known as the Krebs cycle. Now, the two pyruvic acid molecules can move into the mitochondria with the 3-carbon molecules. ATP is used to help start up the movement of these, what would you call brain fart. And they move into the mitochondria, and then they will begin the first cycle of cellular respiration known as the Krebs cycle. And during the Krebs cycle, one carbon molecule will go back into carbon dioxide. And if I was a plant, I'd use it as my energy, but I'm not a plant. I'm a human. So now, these carbon molecules will begin to form with the pyruvic acid and the oxygen that you're breathing and turn into CoA, as a form of acetyl-CoA. And this is made up of 2 carbon atoms, 1 oxygen atom, and 3 hydrogen atoms from some of the air that you're breathing. Remember? O2. Now you have, then, from the cellular respiration that was happening before, because you got to remember this is a whole big cycle, you will make you will add 2 carbonic cellular groups to the 4-carbon molecule, producing a 6-carbon molecule, 6 carbon molecule called citric acid. Now, the citric acid, or also known as the 6 carbon molecule, is now broken down in the Krebs cycle back down to a 4 molecule carbon. The two carbon left over is then turned back and used in the beginning of another one. Like I said, it's a cycle.
Sounds like a cycle.
So, this starts the cycle over again. And this will now be carried with high energy electrons and ATP into the electron transport chain. Did you just say to yourself, something sounds wrong? Well, you're right, because I was testing you. High energy electron carriers are not ATP. They're ADP and NAD+. And if you got it wrong, you better hit your book studying, because that was an easy question. So there should be something wrong. Test time, children. Now, what was oxidized and what was reduced in the Krebs cycle? Beep. Time's up. The oxygen, the water, H2O, was oxidized while the glucose was reduced. If you did not know that, then you will probably end up like the person in this picture. So I suggest going back and studying. The electron transport chain is now going to move H+ ions across the membrane because it takes a lot of energy to move stuff, as in molecules, across the membrane. And for every 2 high energy electrons, 1 H+ ion will be moved across the membrane. And now this helps the inner mitochondria create ATP through ATP synthase. And ATP is a compound that's very high in energy that allows us to do work like wiggle our fingers or talk or make presentations that are creative. Well, my friends, this is the end. If you have any questions, don't come talk to me. Blog to me. I want to see like essays and 30-page papers on this from you. I hear it's all the rage in some pretty awesome social studies classes, so I want to try it out myself. Remember now, blog it up.